Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Rizana. I will present activity 1 for Lab 8. This is the circuit diagram that I drawn in Proteus. Here we can see the AC source where the VAC is 10 and the frequency is 50 Hz. This is emitter with unit milliampere, and this is voltmeter. The value for resistor 1 is 860 ohm, and the value for L1 is 0.4 Henry. So when we run this circuit, we will get the value for emitter is 11.5 milliampere, and for voltmeter is almost 10 volt. Next, I will present the activity 2 for Lab 8. This is the parallel circuit. Here we can see the AC source with 10 volt and 50 Hz. This is the emitter. This is the voltmeter. For resistor, the value is 860 ohm, and for inductor is 0.4 Henry. When we run this circuit, we will get the voltmeter shows the value is 10 volt, and the emitter and the value for emitter is 92.7 milliampere.
Assalamualaikum and salam sejahtera. My name is Siti Nurlina binti Nur Azmi. My matrix number is AE190030. Right now, I am going to explain about activity 3, which are the series resistive capacitive load circuits. So here is the figure for the RC series circuit. It needs us to measure the value of current and voltage for both RC circuit. So this is the simulation that I have set up. For the value of AC source, we use 10 volt and the frequency is 50 Hz. For resistor, I use 390 and the value of capacitor is 2 microfarad. Here is the required that I have to use and record. Now let's run the simulation. As we can see here, the value of current that we got for the RC circuit for the data port number 1 is 4.36 milliampere and 7.07 volt. Next, let's try with the different value of resistor and capacitor. I will use 210 ohm and 4 microfarad. Now I have changed the value of resistor and the capacitor. For the resistor 210 ohm, while the capacitor is 4 microfarad. Now let's run the simulation. From the simulation, we can see that the value of current are different from the earlier. It got 8.67 milliampere, while the value of voltage is still the same, 7.07. Now let's change the value to 860 ohm and 4 microfarad. So here we got the different value for current and also the same value for the voltage. the value of current that we got are 6.02 milliampere, while the value of voltage is still the same, 7.07 volt. So here is the manual calculation for activity 3. We have to convert the value of V, RMS, and next, to find the value of current, we have to find the capacitance first and insert the value of the capacitance into the formula impedance. Set R squared resistance squared plus capacitance squared. Next, we have the value here. And after that, we have to find the value of current. I equals to V supply over impedance. So the table shows the value of calculation circuit and the simulation for the activity 3. So the value of current for the manual calculation and the simulation have quite the same value. Now let's go through the activity 4, which are the parallel resistive capacitive loop circuit. So here we just change the connection of the circuit just in parallel. Okay, now the value of resistor and the capacitor I want to change to 390, and the capacitor is 2 microfarad. Let's change. So now let's run the simulation. So here the value of current that flows through the circuit are 18.6 milliampere, while the value of voltage is 7.07 volt. So here let's try the 210 ohm and the 4 microfarad. Now the value of current that flows are 34.7 milliampere, while the value of voltage here are still the same, 7.07 volt. Okay. Here is the data for the simulation value for the current for the first data until the last one. So now let's go through the manual calculation. So for manual calculation, I have to find the value of the capacitance first, and then I have to insert to the formula impedance, which are for parallel 1 over cert resistance 1 over resistance squared plus 1 over capacitance squared. And when I got the value, I have to insert into the formula I equals to V over R. So the value of V are the 7.071, and the value of impedance is based on the question 1. For the data number 1, 378.793, and I got 18.66 milliamp. So here is the data that I have collected for calculation and the simulation value. For the value of current from the manual calculation and simulation, basically we got the same, almost the same. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Ahmad Amir Hakimi bin Zulkifli. My metric number is AE200008. I will explain the simulation for activity 5. So this is the simulation. I'm using MATLAB to show the simulation. So this is the voltage source, which is the AC source, which is connected to the current measurement as a ammeter and connected to RLC branch series. So this RLC connected to the voltmeter to calculate the V load. So the initial value for RLC series is resistance equal to 390 ohms, inductor equal to 0.4 Henry, and the capacitance equal to 2 microfarad. And when we run, we need to double click the scope to see the value. So for the current, which is the emitter, the value is 3.29, and the value we got for voltage equal to 4.99. So this simulation repeated by changing the value of resistance to 470 ohm. We will get the value for VLOAD and current same as before. But when we change the value of the resistance to 860, the VLOAD will get the same value, but the current will decrease to 30 milliampere. Next, we use the same value of resistance, but we change the value of the inductor to 0.6 Henry. We get the value for VLOAD equal to 50 and the value for current equal to 34 milliampere. Next, the simulation repeated by changing the value of inductor again to 1.0 Henry. The value for VLOAD still got 50, but the value for current we get the 38 milliampere. Next, we change the value of capacitance, which is to 4 microfarad. We get the value for VLOAD 50 and the value for current equal to 65 milliampere. The last one, we will change the capacitance to 8 microfarad. We will get the VLOAD equal to 50 and the value for current equal to 105 milliampere. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Zulkifli bin Bakar, manometry ECE20226. I will present about number 6. Okay, as we know, in the activity number 6, we use the parallel circuit, and it contain 3 of load. Number 1 of load is resistance, number 2 is inductor, and number 3 is capacitor. Okay, when we on the simulation or running the simulation, we can see that the ammeter reading is 299.379 milliampere. When we use the value of resistor is 390 ohm, and the inductor value is 0.4, and the number of capacitor is 8 microfarads. Okay, the value of the ammeter will, or the value of current will decrease follow the value of the load. If the load is increase, and the value of ammeter will decrease, and if the value of load is decrease, and the value of the ammeter will decrease, and the value of the voltmeter is did not have effect, and because it is parallel circuit, and it will fix to the 50 volts like the input voltage. Okay, that's all for me. Thank you.